All right, number 1 is asking you to simplify 5 to the 8th divided by 5 to the 6th. So when you have like bases, you subtract exponents on a division problem. So it's basically just 5 to the 8 minus 6 power. And 8 minus 6 is 2, so you end up with 5 squared, and 5 times 5 is 25. Number 3, I can do 15 divided by 5 and get 3, and then x to the 6th divided by x to the 6th, keep the x, subtract the exponents. So that ends up with 3x to the 0 power, but anything to the 0 power is 1, so really the problem is just 3 times 1, and you get 3. Number 5, I prefer writing this with a division bar. So 2.8 times 10 to the 11th divided by 4 times 10 to the 8th. So you can do 2.8 divided by 4. So 4 goes into 28 7 times, so that's going to be 0.7. Then I can do 10 to the 11th divided by 10 to the 8th by subtracting the exponents. So I end up with 0.7 times 10 to the 3rd power. That's not scientific notation because 0.7 is not a number between 1 and 10. So if I multiply 0.7 by 10, I'm going to get 7. And then, but if I multiply that by 10, I have to divide this by 10 to keep it balanced. So if I subtract 3 minus 1, I'm going to get 7 times 10 squared. And then number 7, same thing. I prefer to write it as division with a fraction bar. So if I do 1.9 divided by 1.9, that's 1. If you do 10 to the 4th divided by 10 to the 4th, you subtract 4 minus 4, you're going to get 10 to the 0. But what's anything to the 0 power? It's 1. So really the whole problem was 1 times 1 to get 1. And number 9, you've got 2/5 squared. So that means you're really doing 2/5 times 2/5. And 2 times 2 is 4, 5 times 5 is 25. Number 11, anytime you have exponents on the inside of parentheses and exponents on the outside, that's power of a power. You have to multiply the exponents on the inside by the exponents on the outside. So the first thing I want to do is simplify the denominator. So I'm going to put a 1 on that b. So I would do a to the 3 times 2 on the bottom, and b to the 1 times 2. And I still have a cubed, and this is still all raised to 2nd power. So I really have a cubed over a to the 6th, b to the 2nd, and that's really what's squared. So any exponent on the inside gets multiplied by an exponent on the outside. So I'm going to have a to the 3 times 2 over a to the 6 times 2 and b to the 2 times 2. So that's going to give me a to the 6th over b to the 12th, b to the 4th, excuse me, a to the 12th. It's an a right there. And then because the a's are alike, I can keep the a and subtract 6 minus 12, and the b to the 4th stays where it's at. So I end up with a to the negative 6th over b to the 4th. But you can't have a negative exponent, so it has to go in the bottom, which means that's just going to leave me with a 1 in the top. I have a to the 6th, b to the 4th. Number 13, I have to do 3/4 to the negative 2nd. Anytime you have a quotient to a negative exponent, you can flip your fraction upside down and make that a positive 2. So I'm really doing 4 squared over 3 squared. 4 times 4 is 16, 3 times 3 is 9. For number 15, 2/3 to the negative 1, you can flip it and make it 3/2 to the positive 1. Then 3a over 2b to the negative 2nd, I can flip that upside down, make that 2b over 3a to the positive 2nd. So this is going to be 3/2, and then 2b over 3a to the 2nd really means 2b over 3a times 2b over 3a. That's the meaning of it. So my 3's can cancel, my 2's can cancel. So I'm going to end up with 2b squared over 3a squared. And then nothing else can cancel.